Are you all back?
Yeah. I'm
Okay,
here.
great. Super. So we're going to start with trigonometry, and this is the textbook section 4.3. The Pythagorean theorem is based upon the sides of a right triangle. So a right triangle is a 90-degree angle. That just means that one of the angles of the triangle is 90 degrees. And let's call the other angles, let's just call one of them theta. Almost always people call the horizontal leg A, the vertical leg B, and the slanted one is not a leg, it's the hypotenuse. And the relationship between these three sides is that the square of A plus the square of B is equal to the square of C. Let's do a couple of questions just on the sides of the triangle, and then we're going to go back up here to the trig part and fill in. So how do I find B if I know that one leg is 12 and the hypotenuse is 13?
Plug it into an equation.
Okay, what do I like? Do we know A, B, C? Which ones do we know?
We
A and
know
C.
A and C.
Okay, great. And so let's see, our formula is A squared plus B squared equals C squared. So that means I've got 12 squared plus B squared equals 13 squared. For our class, it's really helpful to know up to 25, I think, for perfect squares. But definitely up to 13, well, 15. Oh, heck, we get better than that. So 12 times 12 is?
144.
Beautiful. And what about 13 squared?
169.
Excellent. Almost everything that we're doing, especially at the beginning of the class, is no calculator, none, zero. Okay, so I want to find B. What's the next step?
I would subtract 144 from 169.
Excellent. 25. So if B squared is 25, how can I find B?
Square root of 25 is 5.
Yeah, and there's one extra step that I want you to take. So to get to B, I've got to take the square root of both sides. And that means that at least for half a second, there's a plus or minus in front of the square root of 25. Then square root of B squared is B. Square root of 25 is 5. And are we in a physical space? Are these measurements?
Yeah.
And can a measurement be negative? Not
No.
its orientation, but itself. Okay. So we can now ignore the plus or minus, but I want you to think that thought every time you take the square root of both sides, because later we will need both numbers. Okay, so we've got that B is 5. And this is one of the Pythagorean triples that we'll use a lot. 5, 12, 13. A Pythagorean triple is three numbers that are all integers, where the square of the two smaller numbers equals the square of the larger. Another really popular one is 3, 4, 5, because 9 plus 16 is
25.
25. Beautiful. Now, we're going to use the location of theta as our orientator. With respect to theta, B is the side opposite theta. So I'm going to call it opposite. A is the side adjacent or next to. So A is adjacent, and C is the hypotenuse. And we usually use just the first three letters. With adjacent, opposite, and hypotenuse as our guides, and this angle theta, theta is never the right angle. It's always one of the others, and we're choosing to let it be in the lower left. Sine is defined to be opposite over hypotenuse. Cosecant sine is S-I-N-E. Cosecant is C-O-S-E-C-A-N-T, and it's abbreviated CSC. Cosecant is the reciprocal of sine. Do you see that? Opposite over hypotenuse, hypotenuse over opposite. So we're going to think of those together. Cosine is abbreviated COS, and it is adjacent over hypotenuse. The secant is the reciprocal of cosine. Tangent is the only of the three. Tangent is the only one that ignores the hypotenuse. Tangent, and let's write that out. Tangent is opposite over adjacent. Opposite over adjacent. And the cotangent is its reciprocal. So can we write down, with respect to theta, we know that the sides are 12, 5, and 13. Can we write down the six? Let's first just do the sine, cosine, and tangent. Can we find those?
Yeah.
Okay. The sine is going to be, I'm going to write it just really quickly, opposite over hypotenuse. And what is opposite?
B,
5,
B.
And the hypotenuse.
13.
Beautiful. And then we've got cosine. Cosine is adjacent, adjacent over hypotenuse. Adjacent is,
12.
and the hypotenuse is still 13. And then tangent. Tangent is what over what?
5 over 12.
Yes. And it's opposite over adjacent. And I did it in this way because I want you to think about connections as much as possible. The cosecant of theta is the reciprocal of sine, which means it is
5, 13.
13,
Over 5.
good. The secant is the reciprocal of cosine, so it is,
13 over 12.
and the cotangent is the reciprocal of tangent, and it is
12 over 5.
awesome. Do y'all want to do an easy problem together or skip that and plow forward? It's up to you. So y'all decide now.
We have about near 5 minutes left of this class, just to let you know.
Okay, let's go ahead
I
and
bet
plow
we could
forward
do-
then. Oh, say it again. Ben, what were you saying?
Yeah, I'm saying that we should keep going.
Okay, good. So now we have a more interesting looking triangle. Well, it still looks like a right triangle. The adjacent side is 5 units. The opposite side is the square root of 2 units, and we don't know the hypotenuse. So first, how do we find the hypotenuse? What is the formula?
A squared plus B squared.
Equals C squared.
Beautiful. And A is
5.
B.
Square
Square
root
root
of
of
2.
And we're looking for C. 5 squared.
25.
25.
Square root of 2 squared.
2.
25 and 2.
27.
Okay. Obviously, we've got to take the square root of both sides. And just like before, I want you always at this step to put a plus or minus. At the next step, you can say, but these are measurements. These are physical measurements, and the plus or minus goes away. But it will come back. So always do that. Now, that means we've got the square root of 27 equals C. But I can simplify this. 27 is equal to what times what? Any two numbers whose product is 27. There's only
9 and 3.
9 and 3. Good, thank you. So we've got 9 times 3 is 27, and that's helpful because one of those factors is a perfect square. I know that the square root of 9 times 3 is the same thing as the square root of 9 times the square root of 3, and the square root of 9 is
3.
3.
good. So we've got that C is 3 square root of 3. What's our time? Oh, we have 3 minutes. Okay, so we've got 3 square root of 3, and we can start writing down the trig function. So let's see. We know that sine of theta, let's see, that's opposite over hypotenuse. And what was the opposite?
Square root of 2.
Yeah.
And the hypotenuse.
3 square root of 3.
We know that cosine is adjacent over hypotenuse, so it is
5 over 3 square root of 3.
and tangent is opposite over adjacent.
Square root of 2 over 5.
Okay, great. I just want to throw one thing out at you. Two things. One is that Alex will not accept any answer with a radical in the denominator. It'll say it's wrong. That's unfortunate because this is a fine answer. It really doesn't simplify well. Now, on the other hand, this first response is not a fine answer. There are two radicals, one in the numerator, one in the denominator. So we can simplify this one. And let's just, it's called rationalize. Let's rationalize this denominator. When there's only one term, that means we just multiply numerator and denominator by that radical. So square root of 3, square root of 3. In the numerator, we're going to have square root of 2 times the square root of 3. In the denominator, we've got 3, the whole number, times, we've got 2 square root of 3s. So I'm going to write this way, square root of 3 squared. What is the square root of 3 squared?
3.
Good. So in the denominator, we've got 3 times 3, which is
9.
9.
beautiful. And the square root of 2 times the square root of 3 is the square root of 2 times 3, which is the square root of 6. So the reason that square root of 6 over 9 is a better answer than square root of 2 over 3 square root of 3 is that this second answer has only one radical. But you notice that 5 over 3 square root of 3 also has only one radical. And square root of 2 over 5 has only one radical. In math, these are great answers. Alex will not accept 5 over 3 square root of 3, but it will accept square root of 2 over 5. So we need to rationalize 5 over 3 square root of 3. The square root of 3 part is the only issue. So I'm going to multiply numerator and denominator by square root of 3. In the numerator, I've got 5 times the square root of 3. And just like before, we had 3 square root of 3 times the square root of 3, and we got 9. The reason why mathematically this isn't a necessary move is that we still have one radical, which we haven't simplified anything. Okay, I'm going to call it good now. Any questions?
Yes, ma'am. But I would like to talk in private afterwards.
Okay. Any questions before we turn the recording off?
No.
Okay, Andrew?
No. Okay.
Okay, I'm going to turn off the recording.